Our discussion now is going to go to the periodic table, the Bible of this class. The periodic table is incredibly organized. It might look a little weird, but it is organized in not only the mass, or like based on the atomic number, which we'll talk about, but also by properties. Like why isn't it just like a block? Like how come I just don't have a row here and a row here and a row here? Because it's based on properties, and properties are based on the electron configurations, which again we'll talk about more in a different chapter when we talk about quantum mechanics. I kind of want to just point out some of the elements. A lot of the elements make sense. Now, just so you know, you do not have to memorize the elements and the names. I will supply a periodic table that looks almost exactly like this. It won't be in color, but you will pretty much have everything else that you see. So you don't have to memorize names and symbols. If you do take Chem 111, you will eventually have to name them. Memorize them. So you might want to kind of start right now, kind of doing it. It's not that hard. But I just kind of want to point out some weird ones that, kind of don't follow. Like, H for hydrogen, that makes sense. He for helium, and lithium and beryllium, boron, carbon, nitrogen, oxygen. These all make sense. Sodium is kind of the first one that's kind of weird. All right, you have Na, and that is for sodium. All right, a lot of these come from either Latin or the Greek. Okay, for these elements, like sodium was one of the first elements to actually be found and identified, and they named it after the Greek for sodium. I don't remember. I think like natrium, I think is where the Na comes from. I can't remember, but I think there's like 13 or 14 of them that kind of has a weird name to it. Okay, so Na, as we go along, K for potassium, that's kind of a weird one. Fe for iron, ferrous, it comes from I think the Greek word ferrous, which means magnetic. That means magnetic in Greek or Roman, or I can't remember exactly, Latin. Okay, so that's where the Fe comes from. All right, Cu for copper. All right. Let's see, as we're going along here, let's see, next weird one, Ag, silver. Okay, Argentinium, that's where the Ag comes from. There's lots of silver mines in Argentina. That's why they named it Ag. Sn for tin, stannous. Don't remember where the stannous comes from. That's tin. Antimony, Sb. Don't know where the Sb comes from. W, tungsten. Have no idea where that comes from. Oh, wolfram comes from wolfram, which I do not know what that means. But feel free to look these up because it's kind of interesting, the history of a lot of these. Au for gold, aurium, or arium, I think it's pronounced arium. Arium is, I believe, Latin for ore. You know how they talk about a gold ore? What gold ore is it's rock with gold chips trapped inside of the rock. So Au, I think, is Latin for aurium. Lead, Pb, plumbus. That is Latin for plumber, plumbus, I think OUS. So that's where the PB comes from. Lead pipes used to be lead pipes in plumbing, and it's not anymore because lead makes you go crazy. So they don't do that anymore. These ones down here were just kind of discovered recently within the past 10 to 20 years. These are ones that were synthesized. Okay, they are not ones that are found in our natural environment. Okay, they were synthesized. A lot of these down here too are synthesized. Okay, so but I just kind of wanted to give you the ones that were a little different. So how many are there? I think there's 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I miss a few? Like I said, I think there were 13 of them. Well, anyways, it's not really important. I just kind of want to point out a few of them. And just so that you kind of get used to the periodic table, practice looking at this. You're going to be looking at it quite a bit throughout the semester. Oh, mercury. Forgot mercury. I knew there was another one. I was looking right at it. Mercury is another one that's a little off. Okay, so that's the periodic table. Let's talk a little bit about characteristics, because you can see it was organized in ways, and there are numbers everywhere on this thing. You can kind of see that, here's 1A, 2A, and then 3A starts here, 4, 5, 6, 7, 8. Then you have the B's down here, all right? So, I also want to talk about this before we go on. you can kind of see this shadowed area. You kind of see that shadowed area that goes all the way up there. Okay. The reason is because if you notice you have 55, 56, and then notice 57 starts down here. And then 58, 59, all the way to 70, and then it starts back up to 71. And then goes all the way down to 86, 87, 88, and then back down to 89, 90, all the way to 102, and then back up to 103. That's because these periods, these groups, fit in right in that space right there. All right, technically, the periodic table should look like this. Let me erase that. Should look like this, and I think your book has a picture of this, or there is a book where, so you have these two rows, okay, and then you have, and then you have this huge space. You have this come down with these two rows down here, and then this comes back up to, let me erase that for a second. That's not what I wanted. It'll make sense as soon as I start doing it. Like this, and like that. Okay, so this is technically what the periodic table looks like. All right, you got these two rows, the 1A and the 2A, which are these two rows right here. Okay, then you have these two rows down here, which are these two rows here. They squeeze in right here. Then you have these 4 rows, which is this right here, and then you have these 5 rows, which is right there, then the last row right there. Okay, so if you kind of see it, if you kind of take this out, if you take that group out and squeeze this into there, you will have this as your periodic table. All right, I know there's a lot of writing going on, but hopefully that makes sense. If not, please ask me in class and I will kind of show you again. Okay, so the elements, you've got elements, all right? Let me just kind of draw one. You have a carbon with a 6 on top of it. If you look back here, you can see carbon has a 6 on top of it. There are also other numbers down here, not on this periodic table, but I'll show you at the end of the slides that there are other numbers, the atomic mass, which we'll talk about in a second. But the number of protons in an atom's nucleus dictates the identity of the atom, which is also known as the atomic number, Z. This number right here, the top number, is the atomic number. Okay, and they show it with the letter Z. Okay, atomic number. This is the first particle we're going to talk about. Atomic number is the number of protons in that element. So carbon has 6 protons. Period. And that's the identity. That's the identity. So if I have a nucleus and I've got 6 protons in it, okay, it does not matter how many neutrons I have. It does not matter how many electrons I have. If I have a nucleus with 6 protons, I don't care about the neutrons or electrons. This is identified as a carbon atom. Does not matter neutrons or electrons. If, let's say I have a nucleus and I have got 8 protons in it, okay, and let's say I got 1,000 neutrons, all right, and let's say I have 3 electrons. What is the identity of this atom? First of all, this doesn't mean anything for the identity. It's just the number of protons. So 8 protons, that means atomic number 8. So that means we are talking about oxygen. This is an oxygen atom. It does not matter about neutrons or electrons. Those tell me something different. Okay? So the first thing is number of protons is the atomic number. So you can see off this periodic table, all right, actually let me go, no, that's fine. Oh, I'm getting ahead of myself. Let me just kind of erase some of this stuff so that we can kind of see. So if you just look at these numbers, lithium has 3 protons, beryllium has 4 protons, magnesium is 12 protons, 11 protons, 19 protons, 20 protons. How many protons does iron have? Iron, remember iron is Fe. How many protons does iron have? 26. Okay. What if I had 26 protons? Okay. 29,000 electrons, which is not possible, by the way, but let's just pretend it is, and 1 neutron. What element would it be? If you said iron, you are correct. It does not matter how many electrons. It does not matter how many neutrons. This is the identity of the atom. End of story. Okay? So all known elements are arranged by atomic number into the configuration called the periodic table. So if you notice, it's all in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, the periodic table also identifies each element with a chemical symbol. Okay, that can be derived from Greek and Latin. Something else I want to make sure that the symbol, okay, is always a capital letter. Capital letter. Okay, so if you talk about nitrogen, it is a capital N. It is not a lowercase n. If you have a symbol that has two letters in it, it's a capital followed by a lowercase. Okay, so for example, and I want to show you why it's important. Let me erase here. I have something called C, capital O, and something called capital C and lowercase o. Are these the same thing? I hope you said no, not even close. This is a molecule called carbon monoxide, which will kill you. So make sure you have detectors in your house. Capital C, lowercase o is cobalt. They are not even close to the same thing. This is a metal. These are non-metals. This will kill you. Cobalt metal, I'm sure if you ate it, it would probably kill you, but it's very highly unlikely you will be eating cobalt. But, you know, there is a chance you can be poisoned by carbon monoxide if you don't have detectors and your hot water heater or your furnace is not working correctly. Okay, so two totally different things, and the difference is one is lowercase and one is capital. So make sure when you draw the symbols that you draw them appropriately. Okay, here we go. Here's kind of a problem. Identify the element given with atomic number 16. Okay, first of all, what does that mean? Atomic number, that is the number of what? The number of protons, right? They even tell you the element contains 16 protons. All right, so what is it? Okay, I'll give you a second to look in your book. All right, I'll actually go back to here, and what is it? Look for 16, and if you said sulfur, you are correct. Okay? All right, I think this is kind of cool. I kept this in here just to kind of show you because people are interested in real life stuff as far as the elements inside of the body. Okay, so although the human body contains trace amounts of a large variety of elements, nearly 99% is of just 6 different elements. Pretty cool. If you take organic chemistry, you will learn about carbon. Organic chemistry is the study of carbon, which is the backbone of organic molecules. But you can kind of see the 6 common elements: oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. Okay, oxygen, look at that, 65% of our bodies is oxygen. That's because of all the water that's inside of our body. Okay, our bodies are huge percentage. I can't remember. My biology teacher would be upset with me, but I think it's like 70 to 80% water. I don't know if that's correct. Correct me if I'm incorrect in class. All right, but 65% of the atoms in our body is carbon. 18%, I'm sorry, oxygen. 18% is carbon. Then you have some hydrogen, and I believe this is by mass. Okay, there is a lot of hydrogen in our body, but hydrogen is very, very light compared to oxygen. If you were probably to talk about the number of atoms, hydrogen by far would beat out everything. All right, but we're not looking at the number of atoms. We're looking probably at the mass of the elements. All right, then you got nitrogen. Right, nitrogen is in our amino acids, which is protein, which is what our skin, our organs, all these things are made up of that. Calcium is our bones, and phosphorus is in a lot of chemical processes inside our bodies. All right, so I always thought this was kind of cool, the human chemistry, kind of just to show you the percentages of all the atoms. All right, so here's another problem just to kind of get used to these things. All right, calcium, the element is calcium. What is the symbol for calcium? All right, you have your, now I put a periodic table for you on D2L, so you can print that off, or you can use the inside cover of your book, but you should have, so if you want to put it on pause right now, hit pause and do these problems and then come back, because I'm going to go through the answers right now. Okay, so hit pause now. Okay, we are back. I'm assuming you paused it and you are back. So the symbol is capital C, lowercase a. All right, so that should be the symbol for calcium. The atomic number, or the number of protons, that's the same thing, is 20. All right, Cu, not Cu Boulder. But Cu as in copper. all right? And the atomic number, which is the protons, is 29. Now, if you look at your periodic table, you also see numbers at the bottom. So like, for example, copper is 63.55. That's the atomic mass. We're going to talk about that in a bit. Now, look at this. I don't have an element or a symbol. Oh my goodness, how do I figure that out with just the number 13? Unlucky number 13. Well, look for atomic number 13, and it is aluminum. Okay, or as the English call it, aluminium. That's how I know how to spell aluminum, is I actually say aluminium. And that is seriously how English people say aluminum, aluminium. So there you go. Hopefully you guys were able to do that and you kind of understand about protons / atomic number. And we can probably go ahead with the next part of that. All right, so I'm going to pause it right here, and we will pick this up at the next video.